water. So seawater, and think of you have two parallel plate conductors. One. And the space between these plates is basically going to be filled by the seawater. And you connect this to an AC source of that microvoltage. So del V of t is going to be V naught cosine of 2 pi u t. So which means the space between the plates here is going to be seawater, and let's assume that this distance is L, and the area of the plate is A. So the area of the plate is A. Now, from Ohm's law, what should be the how do you relate the current, the conduction current, the free current from Ohm's law Ohm's law, if it's the conductor, then you can say that the voltage at a given time t is equals to the current at that time t times the resistance. So the current then is going to be I of t equals to V of t over R. So how do we find a resistance of a given conductor? If you know the conductivity or the resistivity, we know that the resistivity equals to 1 over conductivity, and that is given, which is 0.32 ohm meter. So from what the general form of Ohm's law, we discussed that one at the beginning of the previous chapter, where we relate the current density K equals to the conductivity times the electric field. So this is the free current, all right? So the free current. That's due to the actual motion of the free charges created by the electric field. So the electric field should be a result of the applied voltage, right? So I can write this electric field in between the two plates. These two plates are connected to this voltage, so the potential, I can express the electric field in between these two in terms of the electric potential as sigma V of t over N. But you know that current density, how do you define it? The current density is going to be just the area, the current that's incident over this area. So if I write this one as I free over the area, that will give me the current density, the free current density. So that's going to be sigma V of t over L, right? So remember, what I wrote here is the free current. So from this, you know that I free is going to be A sigma over L times V of t. So basically, the resistance is going to be what from this equation? Or if you write this one as V of t equals to L A over A sigma times I free. This should be the resistance. So 1 over sigma is the resistivity rho. So this is going to be rho L over A times I free. All right? Yeah. Yeah, so 1 over sigma, I replace it by rho. So basically then the current is going to be the current I free of t over the area is going to be V of t over rho n. So we are given V of t, which is V naught times V naught times cosine of 2 pi mu t over rho n. So that is your free current density. So if you assume that this is the y-axis, z-axis, and x. So the current density J free is going to be V naught over rho n times by cosine of 2 pi mu t along the y. So that's the free current. Now the polarization current, how can I determine the polarization current? So that's the polarization current is due to the polarization of the seawater. The seawater has a higher electrical permittivity compared to a free space. So we know that water is a linear medium, and we know that for a linear medium, the polarization P is equals to what? Epsilon naught chi E, electrical susceptibility, times the electric field. Yes?
How did you find the direction for the free current?
For the free current, I just assumed that this is the y-axis, the direction of the y-axis along this, and the x-axis towards u, and the z-axis upward. It's an assumption, but the current is going to change. It's the function of